This presentation will review the Georgia Standards of Excellence 2OA3, which focuses on working with equal groups of objects to gain foundations for multiplication. 2OA3 states that students will determine whether a group of objects up to 20 has an odd or even number of members. The emphasis is on building conceptual understanding by pairing objects or counting them by twos. Students will also write an equation to express an even number as a sum of two equal addends. Students can use a variety of strategies to determine if a number is even or odd. For example, when asked if 7 is even or odd, Student 1 paired the counters, but had one counter left over. Student 2 tried to make two equal groups, but one group had 4 and the other had 3. Student 3 and 4 used models to draw matching pairs. With the use of concrete manipulatives and counters, students begin to see the repeating patterns of odd and even numbers. Which of these shapes show an even amount?
These two.
Okay, so how many red squares do you see?
6.
And even though they're not in equal rows, they're still even?
Yes.
How do you know they're even?
Because you can divide them up 3.
So 2 equal groups means it's even. Can this one be divided into 2 equal groups?
Yes.
4 and 4. What about this one? They're all equal rows. Is it even or odd?
Odd.
And how do you know?
They can be divided into 3 groups. They can't be divided into 2. They have to be divided into 2
and
groups.
So, yes, even has to be 2 groups. Can you divide that into 2 equal groups?
No.
No. What about 3? Can you divide 3 into 2 equal groups?
No, because you can't do this. Can't do this.
So there's always one left out. There are many hands-on games and tasks that can be incorporated into the classroom. In even odd counters, students grab a handful of counters and make pairs to determine if the quantity is even or odd. They then explain to their partner how they know. In a similar task, students estimate how many counters they think they can grab before making pairs. They then find the difference between their prediction and the actual amount. How many do you think you're going to be able to grab?
8.
And is 8 even or odd, do you think?
Even.
Even. See how many you grab. Okay, let's make pairs. That's a lot. How many pairs can you make?
Oh, they're all pairs.
All pairs. Does that mean it is an even number?
Yes.
But if you have 7 pairs, what is the actual amount? Count
2, 4, 6, 8, 10, 12, 14.
And what's the difference between the amount that you drew and what you predicted? 14 minus 8.
This one's more higher.
You have more. Let's take away 8. 2, 4, 6, 8. How many's left over?
4, 6.
Cuisenaire rods are another great tool for exploring odd and even. By using the 1 centimeter rods to build larger numbers, students are able to visualize pairs and leftovers. So how long is the orange rod?
10 centimeters.
And how long is the blue rod?
9 centimeters.
So is the red or the orange rod odd or even?
Even.
And what about the blue rod?
Odd.
How do you know?
Because if you build it with 2s, there's going to be 1 left.
Okay, so we have 2, 4, 6, 8, but 1 left over. What about the number 10? Can you build it with 2s?
Yeah.
So which of your rods make an even number?
4 and 6.
How do you know?
3, because 6 can be separated into 2 groups that equal 3. And 4 can be created in 2 equal groups of 2.
As students explore the rods, they begin to notice that all counting numbers alternate between even and odd. These patterns can then be applied to other models, such as number lines and hundreds charts. The doubles facts, including adding an even to an even number, as well as adding an odd to an odd number, created even sums that could be divided into 2 equal groups with no leftovers. But adding an even number to an odd number could not be divided into 2 equal groups. According to Van de Waal, the number endings of 0, 2, 4, 6, and 8 are only an interesting and useful pattern or observation and should not be used as the definition of an even number. So how many dice do you have?
I have 3.
And how many dice do you have?
3.
So is 3 an odd or even number?
Odd.
Odd. How do you know?
Because this one doesn't have a pair.
Okay, so you have a pair with 1 left over. What happens when you add an odd with an odd?
It becomes an even number.
Why does that happen?
Because they became half.
Well, there's 2 equal halves. That's
They
one.
all have a pair.
They all have a pair.
6.
So how did that middle group become a pair?
Because these 2 came together, and these 2 already had a pair.
So does an odd plus an odd always make it even?
Yes.
To explore adding odds to odds and evens to evens further, students can play 2 odds make an even using Cuisenaire rods. The directions to this game are included below the presentation. Okay, so roll your dice and see if you get an odd or an even number.
So I roll it and see if I get
Okay, it's a 1. Is that odd or even?
odd.
Okay, roll your dice again.
It's a 4, so I might need a 3.
A 3. So you can pick one that's 1 less or 1 more, and you completely covered a rod. Good job. Okay, roll your dice again. What did you get? Another 4, so it could be either a 3 or a 5, since we only want to pick odds. Now roll the dice again. A 6. So you could do 1 less or 1 more. What do you think you're going to do? What would 1 less than 6 be?
5. So I get a 3 right there.
You've covered another one. Great job. To help students deepen their understanding of even and odd, there are many great literature connections. For additional support and resources, please check out Unit 6 in the Georgia Frameworks. Rich tasks help define the meaning of odd and even, much more than a rhyme or riddle.